So what's up, guys? So today we are going to design an inverter which can convert 10 volt DC to 120 volt AC using PWM technology. So let me share my screen. So let me bring the LT spice here. So here I have my LT spice. So here I'm using LT spice 17. So here I have this circuit. I have already simulated this circuit. I've already designed this inverter, and today I'm going to talk about like how to design that one like actually from scratch. So let me describe each component over here. So here I have 10 volt DC source. So which one is V1, and I'm using 4 MOSFETs. These are like IRF international rectifier. It has 5302D. These all are same. So these all are NAMOS. So and I'm also using 4 diodes. So this configuration is in full wave. You can see here like one MOSFET over here, another over here, another over here, and another over here. So it gets a full wave. So here we are using diode because here we have inductive load over here. That's why we are using diode over here. So basically how this circuit is going to work. So this is I'm going to explain. So here I am using pulse. That is PWM like. So for that one, the gate is driven by the pulse. So this MOSFET M1 and M4. M4, these are like when these are on, the other MOSFET M3 and M2 needs to off. So when suppose if the MOSFET M1 and M4 is on, then the current is going to flow from here to here. So first we need to convert 10 volt DC to 10 volt AC. Then after we need to step up that voltage to 120 volt. So for a step up, what we need to do, suppose like here I have L1 100M, right? And L2 I'm using 14.4. So we don't need to use just this value. So in order to come with the exact value, we need to use the formula from magnetic class. For example, L is directly proportional to N square, the number of turn square. And for the transformer, for a step-up transformer, the B2 is voltage in secondary. V2 over V1 should be equal to N2 over N1. So for example, here we need to get 120 volt at secondary, and we have 10 volt. So we can get the ratio over here. So V2 over V1, it should be like 12. And so the N2 over N1, the ratio is the secondary and primary turn ratio is equal to 12. So for to find the value for the inductance, we just need to square the turn ratio. So for example, 144 for the secondary and 1 for the primary for inductance values. So here I'm just using like 0.1, 0.1 Henry, and here for secondary I have 14.4, and here I'm using for the load 1K resistance, but you can change any other values. So here pulse, let's see pulse over here. So for the pulse, so for V initial, I have 0. The on voltage is 10. For the MOSFET to drive the MOSFET, we need to have like at least 10. Like if another one, I'm going to show you the other one also, like using NPN transistor. For that one, I have just 2.5 volt. But here for MOSFET, we need 10 volt. The delay time is 0. Time rise is 1 nano. Time fall is 1 nano. And the period is 0.5 m. Timer 1 is like 0.5 m and period is 1 m. So the duty cycle is almost 50%. And for these are for just for the cycles. And you can skip this part. So just like this one, I have also for this one the V3. So V3 and V5, they have like exact same. Here 0.10, 0.5 m, time delay 1 nano, time for 1 nano, timer 1, 0.5 millisecond, time period 1 millisecond, and cycle 100. For like V5 and V3 has same, and V2 and V4 has same. And we have inductance over here. You can also put some kind of other resistive load over here. So let's simulate this circuit. Here, let's check the voltage in primary voltage. So here we are getting 10 volts. If you look over here, it should be just opposite. Let me add load over here. So here you see for the inverter, when here is maximum like 10 volt, here is the peak, and here is 0 volts. 10 0 0 10, like 10 0, and here 0 and 10, just like that. So we have this, and we can also plot the difference of over here. So these are difference for node 4 and node 5. Now I'm going to see the voltage over here. So here we can see over here. Oh, I didn't read that one, that's why it's giving like 2. So maybe we can just say it over here. We can just say plot for the output of the secondary here. So you can see here we have a square wave which is going back and forth 120 volt minus 120 volt. So this is sine wave. So the circuit is just like this. For transformer to work, we need to specify the values like K1, L1, L2, and 1. The coupling constant we are assuming it's one like perfect coupling. It's like ideal condition for actual like for practically design. We cannot have like one for the coupling coefficient. So these are this one, and now I'm going to show you the other one using using NPN transistor. So this is NPN transistor. So this is NPN transistor. For this one, I'm just using the pulse for the voltage gate driver like 2.5 volt, and V2 and V4 they have like same, and V3 and V5 have same. Well, we can simulate this circuit also. Let's measure voltage over here. So here we have 10 volt. We can add plot for here. So just like this, you see here like here 10, here 0, 10, 0, 0, 10, and we can also add one more plot to find the voltage difference between these nodes. So here we have 10 volt minus 10 volts. Here you can see I have like 10 ohm resistor over here. So this is inverter design. I hope you like this video. Maybe next time I'm going to build from scratch